Hello, in this lecture we will find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a polygon with 6 equal sides and 6 equal angles. Okay, all the 6 sides here are equal to each other, and those 6 angles in this regular hexagon are also equal to each other. We also know that the length of one side of this regular hexagon, side AB, it is equal to 2 units. And therefore all the other sides must be also equal to 2 units. So here you can write down that side FE equals to 2 units, side AF equals to 2 units, side ED equals to 2 units, side DC equals to 2 units, and side BC also equals to 2 units. And we also know that line segment PB, this line segment, is equal to 3 units. And our mission is to find out the length of this line segment AP, that is equal to X. Okay, so first of all we find out what is the sum of the angles in any regular hexagon. So I draw a regular hexagon and we find out what is the sum of the angles in the polygon hexagon, in the regular hexagon. So here we have a regular hexagon. So this is a regular hexagon. A, B, C, D, E, F. We will join points B and D together by a straight line. By joining points B and D, we created here 2 quadrilaterals. Quadrilateral ABFE, this quadrilateral, and quadrilateral BCED. We have already know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral ABFE, it is equal to 360 degrees. Likewise, the sum of the angles in quadrilateral BCED, this quadrilateral, it is also equal to 360 degrees. So it is obvious that the sum of the angles in both quadrilaterals will be equal to the sum of the angles in this regular hexagon. So the sum of the angles in those 2 quadrilaterals is 360 degrees plus 360 degrees. That is to say, it is equal to 720 degrees. So we actually found out that the sum of the angles in any regular hexagon, it is equal to 370 degrees. And because of the fact that any polygon hexagon has 6 equal angles, 6 equal interior angles, those 2, 4, 6, all those angles are equal to each other. So actually the sum of all angles, all the 6 angles, the sum of all the 6 angles, it is equal to 720 degrees. So 720 degrees, that is the sum of the 6 angles over 6, will be equal to the size of one angle. Why? Because they are equal to each other. So 720 degrees over 6 equals to 120 degrees. We actually found out that each angle of this regular hexagon, it is equal to 120 degrees in its size. Okay, so here we can write down that angle, this angle equals to 120 degrees. This angle equals to 120 degrees. This angle equals to 120 degrees. This angle is also equal to 120 degrees. And this angle equals to 120 degrees, and this angle is also equal to 120 degrees. So in the next step, we will extend side DC of this regular hexagon by a straight line. Here, extended side DC by a straight line, we will define this point as L. DC is one side of this polygon, of this regular hexagon, and it's a side of regular hexagon DC. It is absolutely a straight line. We extended the straight line DC by a straight line, and this way we got line segment DL. When you extend the straight line by straight line, the result must be a straight line. So DL is a straight line. We can write down that line segment DL, this line segment is a straight line. I will remind you, rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? The sum of the angles on one side of a straight line is equal to 180 degrees. So here, the straight line DL has two sides, this side and this side. So if we focus on this side of the straight line DL at point C, according to rule number 1, the sum of the angles at this side of PL at point C must be equal to 180 degrees. So which angles we have at this side of DL at point C? We have this angle that is equal to 120 degrees, plus the missing angle, plus actually angle BCL, the missing angle. In total, the sum of the angles must be equal to 180 degrees. So at the can say it is the lower side of the straight line DL at point C, according to rule number 1, the sum of the angles at lower side of DL at point C, the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL at point C? We have 120 degrees plus the missing angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. Repeat again. We will focus on at the lower side of the straight line DL at point C. In the lower side of DL at point C, the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at the lower side of DL at point C? We have 120 degrees plus the missing angle, this is angle BCL, in total must be equal to 180 degrees. We will subtract 120 degrees from this equation, and we get that the missing angle BCL equals to 60 degrees. Okay, this angle equals to 60 degrees in its size. In the next step, from point B, we will go perpendicular on DL. Again, from point B, we will go perpendicular on DL. So if this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DL as M. By doing this construction, we render here the right triangle CBM. The right triangle CBM. This right triangle. So I'll copy this right triangle in a new page and we'll analyze it. The right triangle CBM. This right triangle. So actually this is the right triangle CBM that I copied from the original drawing. The hypotenuse CB equals to 2 units. angle BCM. This angle equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to our construction. So in the right triangle, triangle CBM, we know that cosine 60 degrees equals to CM over CB. Repeat again. Cosine 60 degrees equals to CM over the hypotenuse CB. CM is the missing 9 seconds, so we will leave it as it is. CB equals to 2 units, therefore we substitute CB by 2. And cosine 60 degrees is 1/2. So we substitute cosine 60 degrees by 1/2. So cosine 60 degrees, it is 1/2. And it is equal to CM over 2. 1/2 equals to CM over 2. Here we will multiply this equation by 2. And we'll get that CM equals to 1. If we know that CM equals to 1 unit, we can write down in the original drawing that CM equals to 1 unit. Likewise, we will continue to focus on the right triangle, triangle CBM. In this right triangle, triangle CBM, sinus 60 degrees equals to BM over BC. Repeat again, sinus 60 degrees in this right triangle CBM equals to BM over BC. BM is the missing 9 segments, so we will leave it as it is. And BC equals to 2 units, therefore we substitute BC by 2. And sinus 60 degrees equals to the square root of 3 over 2. And it is equal to BM over 2. BM over 2. So in conclusion, we found out that square root of 3 over 2 equals to BM over 2. Here we will multiply this equation by 2. And we'll get that BM side BM equals to the square root of 3 units in its length. Here, BM equals to the square root of 3 units. You can write down in the original drawing that BM equals to the square root of 3 units. Okay? In the next step, we will focus on the right triangle, triangle PMB. This right triangle, triangle PMB, so I will copy triangle PMB in the new page and we will implement in this right triangle, triangle PMB, the Pythagoras theorem. CM equals to 1 units. PC is unknown, so we will define PC as A, and therefore PM equals to PC plus CM. That is to say, PM equals to A plus 1. BM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units. So I'll copy this right triangle in a new page, and we'll implement here with this right triangle the Pythagoras theorem in order to find out the value of A, or the length of right segment PC. So actually, this is the right triangle PMB, that they come from the original drawing. Side BM equals to A plus 1 units. BM, we already found out that BM equals to the square root of 3 units, and BP, the hypotenuse BP equals to 3 units according to what is given us in the question. So here we will implement here the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. Actually, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the square of the perpendiculars. The hypotenuse in this right triangle PMB is PB, and therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the square of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. So according to the Pythagoras theorem, in the right triangle PBM, PB squared equals to PM squared plus BM squared. PB equals to 3 units, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM equals to A plus 1, therefore PM squared equals to A plus 1 squared plus BM squared. BM equals to the square root of 3 units, therefore BM squared equals to the square root of 3 squared. So in conclusion, found out that 9 equals to A plus 1 squared plus square root of 3 squared. So 9 equals to A plus 1 squared. We'll find out the value of this expression, A plus 1 squared is actually A plus 1 squared equals to, according to the algebraic identity, that A plus B squared equals to A squared plus B squared plus 2 times AB. We get that the value of A plus 1 squared in our specific expression, A equals to A and B equals to 1, B equals to 1. I'll check again that I didn't make any mistake here. PC is A, CM is 1, therefore PM is A plus 1, PB is 3, and BM is square root of 3 units. So in our specific expression, A plus 1 squared, the value of A is A, and the value of B is 1. And according to this trigonometric identity, A plus B squared equals to A squared, so it is A squared is A squared plus B squared. B squared is 1 squared and plus 2AB is plus 2A. And so A plus 1 squared, according to this trigonometric identity, equals to A squared plus 1 plus 2A and square root of 3 square is 3. Okay, so here I will do it in another way. Here we have actually quadratic equation, but we can do it in much easier way. Actually, we have the equation that 9 equals to a plus 1 square plus square root of 3 square. So 9 equals to a plus 1 square, and square root of 3 square is 3, so it is plus 3. Here we subtract 3 from this equation, and we will get that 9 minus 3 is 6, so 6 equals to a plus 1 square. Here we'll take a root out of this equation, and we will get that the square root of 6 equals to a plus 1. So here we'll subtract 1 from this equation, and we'll get finally that a equals to the square root of 6 minus 1 units. Okay, so we found that a equals to the square root of 6 minus 1 units. Okay, in the next step, we will join points A and C together by a straight line. By joining points A and C, we get the triangle ABC. So I'll copy triangle ABC in a new page, and we will implement in this triangle ABC the law of cosines in order to find out the length of side AC. Okay. But before that, what is the size of angle ABC? This angle ABC is 1 out of 6 angles of this regular hexagon, and we already found out that all the 6 angles of this regular hexagon are equal to each other, and each of them is equal to 120 degrees. Therefore ABC, the size of angle ABC equals to 120 degrees. And now we'll copy this triangle ABC, and we will implement in this triangle the law of cosines in order to find out the length of the side AC. side AB equals to 2 units and side BC also equal to 2 units in its length. Why? Because those two sides of triangle ABC are also the sides of this regular hexagon, and we already found out that all the sides of this regular hexagon are equal to each other, and each of them is equal to 2 units. So actually, this is triangle ABC that I copied from the original drawing. As I already mentioned before, angle ABC equals to 180 degrees, side AB equals to 2 units, side BC also equals to 2 units. And our mission is to find out the length of side AC. This is the only side that is missing, so we will implement here the law of cosines in order to find out the length of side AC. According to the law of cosines, the law of cosines is true in any triangle. So if we have here triangle ABC, that could be any triangle, not necessarily this triangle, but any other triangle. This is triangle ABC. The angle between side AB and side AC is theta. Side AB equals to A units in its length. The length of side AB is A. Side AC equals to B units in its length. And finally, side BC equals to C units in its length. According to the law of cosines, we get that this triangle ABC, that could be any triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Repeat again, in any triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, we can implement rule number, the law of cosines in our triangle, because the law of cosines is true in any triangle. So, according to the law of cosines, if we implement the law of cosines in our triangle ABC, we get that AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. Okay, this equation is the implementation of the law of cosines in our triangle, this triangle ABC. So AC squared equals to AB squared. Here AB equals to 2 units, therefore AB squared is 2 squared is 4, plus BC squared. BC equals to 2 units, therefore BC squared is 2 squared is also 4, minus 2 times AB is 2, BC is also 2, and cosine 120 degrees is minus 1/2. Okay. So first of all, we have here minus times minus is plus, so this number will be positive. 2 times 2 is 4, and 2 over 2 is 1, so 2 will get cancelled, and we left only this expression in total equals to 4. So AC squared equals to 4 plus 4 plus 4 plus 4 plus 4 plus 4 is 12. So AC squared equals to 12. Here we substitute 12 by 4 times 3, and then we get that AC squared equals to 4 times 3. Here we take out of this equation, and we get that AC equals to the square root of 4 times 3. The square root of 4 is 2, so we can take 4 out of the root, and we get that AC equals to the square root of 4 is 2 times square root of 3. And inside the root we left only 3. So in conclusion, we found out that AC equals to 2 times square root of 3 units. Okay. Here we can write down that side AC equals to 2 times square root of 3 units. Okay. We will continue to focus on triangle ABC. So I'll copy triangle ABC again. So actually, this is triangle ABC that I code from the original drawing, and because of the fact that the triangle ABC side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two sides that are equal to each other, we have those two angles that are also must be equal to each other. So if we define angle ACB as x, then angle BAC must be also equal to x. Okay? And you also know that the sum of the angles in any triangle is equal to 180 degrees. And especially, the rule is true in our triangle, triangle ABC. So which angles we have in this triangle, triangle ABC? We have x plus 120 degrees. In total, it must be equal to 180 degrees. So x plus x is 2x, 2x plus 120 degrees equals to 180 degrees. Here we subtract 120 degrees from this equation, and we get that 2x equals to 180 degrees minus 120 degrees is 60 degrees. So x equals to 60 degrees. Here we divide this equation by 2, and we get that x equals to 30 degrees. Okay. Here x equals to 30 degrees. And this again is the angle ACB. It is also equal to 30 degrees. So we actually can write down here angle ACB equals to 30 degrees. This is angle ACB and it is equal to 30 degrees. So I'll copy the angles in a new page and we'll find out the size of this angle, angle PCA. First of all, angle PCB angle PCB equals to 120 degrees. Angle ACB equals to 30 degrees. Okay, again, I copied the two angles in this drawing here. This is angle PCA that is equal to 120 degrees. This angle in the red color, angle ACB, equals to 30 degrees. Therefore, it is very easy to see that the big angle, that is 120 degrees, minus the small angle that is 30 degrees equals to angle PCA. Okay, so you can write down that angle PCA, the missing angle, this angle, this is the missing angle, and it is actually equals to the value of the big angle that is actually 120 degrees minus the value of angle ACB that is 30 degrees, and 120 degrees minus 30 degrees, it is 90 degrees. So we found out that angle PCA, this angle, equals to 90 degrees. Okay, so we can write down here that this angle, angle PCA, is a right angle, it is equal to 90 degrees. Okay, and because of the fact that this angle, angle PCA, equals to 90 degrees, it means that triangle PCA is a right angle. So I will copy the right green triangle, triangle APC, in a new page, and we will implement the Pythagoras theorem on this green right triangle, triangle PCA. Okay. So actually this is the right triangle PCA. This is the code from the original drawing. We just right now found out that this angle PCA equals to 90 degrees. Therefore, triangle PCA is the right triangle. AB is the missing line segment. The AP is the missing line segment, and it is equal to x. So we have to find out the value of AP that is equal to x. We have already found out that AC equals to 2 times square root of 3 units, and we have already found out that PC that is equal to A equals to the square root of 6 minus 1 unit. So we will implement here the Pythagoras theorem in order to find out the value of x, that is the value that we are looking for in this question. So here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle APC is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. I repeat again, according to the Pythagoras theorem in the right triangle APC, AP squared equals to PC squared plus AC squared. Here AP equals to x, therefore AP squared is x squared, and it is equal to PC squared. PC equals to the square root of 6 minus 1, therefore PC squared is the square root of 6 minus 1 squared, plus AC squared. AC equals to 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. Okay. So x squared equals to the value of this expression, square root of 6 minus 1 squared. We will find out the value of this expression, square root of 6 minus 1 squared, according to the algebraic identity that A minus B squared equals to A squared plus B squared minus 2 times A times B. In our specific expression, A equals to the square root of 6 units and B equals to 1. And this expression, square root of 6 minus 1 squared, must be equal to A squared, square root of 6, A equals to the square root of 6, therefore A squared is square root of 6 squared, that is 6, plus B squared. B equals to 1, therefore B squared is 1 squared, that is 1, minus 2 times A times B, minus 2 times square root of 6 times 1. So we found out that x equals to 6 plus 1 minus 2 times root of 6, but actually the value of this expression, square root of 6 minus 1 square, according to this trigonometric identity, equals to 6 plus 1 minus 2 times root of 6 units. But we should not forget this expression also. Square root of 2 times square root of 3 squared is 2 squared, that is 4, and square root of 3 squared is 3. And 4 times 3 is 12. In conclusion, we found out that x squared equals to 6 plus 1 plus 12 minus 2 times root of 6. So x squared equals to 6 plus 1 is 7, and 7 plus 12 is 19. So it is 19 minus 2 times square root of 6. Here we take out of this equation, and we found out that x equals to 19 minus 2 times root of 6. Here we took a root of this equation, x equals to 19 minus square root of 6. When we took a root on both sides, both sides of the equation. The square root of x squared is x, and the square root of 19 minus 2 times root of 6 is actually the square root of 19 minus 2 times root of 6. Okay, so x equals to the line segment that we are looking for. This question is AP that is equal to x. This line segment is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers it is equal to 3.755 units. Okay, so we finished the question. And so here that x equals to 3.755 units. In the next step, I will summarize the lecture. So, in the drawing, we have a regular hexagon. A regular hexagon is a polygon with 6 equal sides and 6 equal angles. Okay, so because of the fact that side AB equals to 2 units, then all the other sides must be equal to each other. That is to say, all the sides of this regular hexagon are equal to 2 units. And we also know that line segment BB equals to 3 units in its length, and we have to find out the value of AP that is equal to x. So first of all, we found what is the sum of the angles in any regular hexagon. So I draw this regular hexagon that is A, B, C, D, E, F, and we join points B and D together by a straight line. In this way, we created those two quadrilaterals. The sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral ABFE is 360 degrees, and the sum of the angles in quadrilateral BCED is also equal to 360 degrees, and the sum of the angles on those two quadrilaterals in total will be equal to the sum of the angles of this regular hexagon. So the sum of the angles both in total on those two quadrilaterals will be equal to 360 degrees plus 360 degrees, that is 720 degrees. So the sum of the angles is 720 degrees, and we also know that any polygon hexagon has 6 equal angles. So the sum of the total angles over the number of angles that this polygon regular hexagon has will be equal to the size of one angle. Why? Because of the fact that all the angles in this regular hexagon are equal to each other. So the sum of the angles in this regular hexagon is 720 degrees over the number of angles that this polygon hexagon has, that is regular hexagon has, is 6. So it is 720 degrees over 6 is 120 degrees. So we found out that each the size of each angle this in our polygon hexagon is 120 degrees, and we already found out that all the angles in this regular hexagon are equal to each other, and each angle is equal to 180 degrees. All the sides are also equal to each other. Each side is equal to 2 units. Okay. So in the next step, extended side DC by straight line. DC is one side of this regular hexagon, therefore it is absolutely a straight line. And then we extended the straight line DC by straight line. The result DL must be also a straight line. I fill again. DL is a straight line. Okay, and if you focus on this side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. Okay, at point at the lower side of DL at point C, the sum of the angles must be equal to 180 degrees. So we can just, we have at the lower side of the straight line DL at point C, we have this angle that is equal to this angle that is equal to 120 degrees plus the missing angle, and get BCM. In total they must be equal to 180 degrees according to rule number 1. Repeat again. 120 degrees plus the missing angle BCM must be equal to 180 degrees according to rule number 1. Here we subtracted 120 degrees from this equation, and we found out that the missing angle BCL is equal to 60 degrees. Okay. So this angle equals to 60 degrees. In the next step, from point B, we draw perpendicular on DL. From point B, we draw perpendicular on DL. So this angle equals to 90 degrees, and this angle equals to 90 degrees, according to our constructions. Then we focus on triangle CBM. I copied triangle CBM in a new page here. This is triangle CBM. This angle equals to 90 degrees according to our construction, and this angle equals to 60 degrees according to rule number 1. So here we can say that cosine 60 degrees equals to CM over CB. Okay. Again, cosine 60 degrees equals to CM over CM over the hypotenuse BC. So it is actually CM over BC. CM is the missing line segment, so we leave it as it is, and BC equals to 2 units. Therefore, in total, we found out that cosine 60 degrees equals to CM over 2. The value of cosine 60 degrees is 1/2. So we substitute cosine 60 degrees by 1/2, and we got that 1/2 equals to CM over 2. We multiplied this equation by 2, and we found out that the missing line segment CM, and the missing side this is inside side CM equals to 1 unit. Then in this triangle CBM, sine of 60 degrees equals to MB over the hypotenuse BC. Again, sine of 60 degrees equals to MB or BM over BC. Okay, it is sin 60 degrees equals to BM over BC. Okay, for BM is the missing line segment, so we leave it as it is over BC. BC is 2, therefore we can substitute BC by 2. Sin of 60 degrees equals to square root of 3 over 2. We substitute sin of 60 degrees by square root of 3 over 2, and it is equal to Bm over 2. Here we multiply this equation by 2 and found out that Bm equals to the square root of 3 units. Here, Bm equals to the square root of 3 units. Then we focus on the right triangle PBM, so I copy triangle PBM in a new page and we analyze it. We actually implemented it on the Pythagoras theorem. It is given us the equation that PB equals to 3 units. We already found out that BM equals to the square root of 3 units, and PM equals to A plus 1. So when I show you here, PM equals to A plus 1. Okay. So PB equals to 3 units, therefore PB square is 3 square, and it is equal to PM square. PA is A plus 1, therefore PM square is A plus 1 square, plus BM square. BM is square root of 3, therefore BM square is square root of 3 over 2. Okay. So PB equals to the square root of 3 units, therefore PB equals to 3 units. You can see here, therefore PB square is 3 square, that is 9, and it is equal to PM square. PM equals to A plus 1, therefore PM square equals to A plus 1 square, plus BM square. BM equals to the square root of 3, therefore BM square equals to the square root of 3 square. Okay, so 9 equals to here we have 9 equals to A plus 1 square plus square root of 3 square. Square root of 3 square is 3, so in total we found out that 9 equals to A plus 1 square plus 3. Okay. Again, 9 equals to A plus 1 square, and the square root of 3 square is 3. So we already found out that 9 equals to A plus 1 square plus 3. Here we subtracted 3 from this equation. We found out that 9 minus 3 is 6, and 6 equals to A plus 1 square. Here we took out of this equation and we found out that the square root of 6 equals to A plus 1. Okay. Here we subtracted 1 from this equation. We found out finally that A equals to the square root of 6 minus 1 square. Okay. Here I found out that A equals to the square root of 6 minus 1 square. Okay. In the next step, we join points A and C together by a straight line. Points A and C together by a straight line. By joining points A and C, we created here triangle ABC. This triangle ABC. Okay. Angle ABC is 1 out of 6 angles of this regular hexagon, therefore it is equal to 120 degrees. AB equals to 2 units, and here BC it is also equals to 2 units. So I copied triangle ABC in a new page. This is triangle ABC that I copied from the original drawing. Repeat again that AB equals to 2 units, BC equals to 2 units. They are both the sides of not only of this triangle, but they are also the sides of the regular hexagon, and all the sides of the regular hexagon are equal to each other, and they are equal to 2 units. Each of them equals to 2 units. repeat again that this angle equals to 120 degrees. It is because of the fact that it is 1 out of 6 angles of the regular hexagon, and all the angles of the all the two angles of the regular hexagon are equal to each other, and each of them equals to 120 degrees. Then we implemented the law of cosines in this triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. So this triangle ABC could be any triangle. The length of side AB is A units, the length of side AC is B units, and side BC equals to C units in this length. Then, according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine 120 degrees. Again, this is the law of cosines that is true in any triangle. So here C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, so we can implement this rule number 5 in our drawing. Why? Because in our drawing we have triangle ABC, that could be any triangle. We want to find out the length of side AC, and according to the law of cosines, we get that AC squared equals to AB squared plus BC squared minus 2 times AB times BC times 120 degrees. Okay, repeat again, AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. Okay, so AC squared equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BC squared. BC is 2, therefore BC squared is 2 squared, that is 4. Okay, and we have cosine 120 degrees, that is minus 1/2. So in conclusion, we found out that AC squared equals to 4 plus 4 minus 2 times 2 times 2 over 2. 2 over 2 is 1, so in total we have only 2 times 2, that is 4. Okay, we have here minus times minus, that is plus. So this number in total must be plus. Okay, so in conclusion we found out that AC squared equals to 4 plus 4 plus 4, that is 12. Then we substituted 12 by 4 times 3, so AC squared equals to 4 times 3. Then we took out of this equation, we found out that AC equals to the square root of 4 times C. Okay, repeat again, we found out here that AC equals to 2 times square root of 3 units. Then I copy triangle ABC again in order to find out the angles, the missing 2 angles. So this is triangle ABC that I copied from the original drawing. This angle equals to 120 degrees. We have side AB that is equal to side BC. And according to rule, the rule that said that in front of equal sides in the triangle there are equal angles, we get that these 2 angles that are located in front of equal sides must be also equal to each other. So if this angle is x, then this angle must be also equal to x. Okay? And we also know that the sum of the angles in any triangle is equal to 180 degrees, especially in triangle ABC. So which angles we have in triangle ABC? We have this angle is x, this angle is x, and 120 degrees. So x plus x plus 120 degrees must be equal to 180 degrees. So x plus x is 2x, and so 2x plus 120 degrees equals to 180 degrees. Here we subtracted 120 degrees from this equation and found out that 2x equals to 60 degrees. And then we have, so we found out that x equals to 30 degrees. But x is angle ACB, and we found out that this angle ACB equals to 30 degrees. So we know that angle PCB, the big angle PCB equals to 120 degrees. We know that the small angle ACB equals to 30 degrees. So what is the big angle PCA minus the small angle ACB will be equal to the size of this angle. That is to say, the size of this missing angle equals to 120 degrees minus 40 degrees, that is 90 degrees. So in conclusion, we found out that the missing angle PCA equals to 90 degrees. And therefore the triangle PCA must be also a right triangle. So in the next step we implemented the Pythagoras theorem on the right green triangle PCA. Okay. So actually this is the right triangle PCA that I copied from the original drawing. And side AB equals to x units in its length. We already found out that AB equals to 2 times square root of 3 units, and finally CP equals to A equals to the square root of 6 minus 1 units. So we implemented here the Pythagoras theorem. By PT is the version for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is AP, therefore the square of the hypotenuse is AP square. It must be equal to DC square plus CA square. Okay, so AP equals to x, therefore AP square is x square, and it is equal to DC square. Okay, repeat again, AP equals to x, therefore AP square is x square, and DC, here PC equals to the square root of 6 minus 1 units, therefore PC square equals to the square root of 6 minus 1 square plus AC square. AC equals to 2 times square root of 3, therefore AC square equals to 2 times square root of 3 square. Okay, so we found out that x square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. Okay, in order to find out the value of square root of 6 minus 1 square, we use the trigonometric identity that a minus b square equals to a square plus b square minus 2 times ab. Here the value of a in our specific expression is equal to the square root of 6, and the value of b is 1. And according to this trigonometric identity, a minus b square equals to a square plus b square minus 2ab, we get that x square equals to a square is square root of 6, therefore a square is square root of 6 square, that is 6. Plus b square, b is 1, so b square is 1 square, this is 1 also. Minus 2 times a is square root of 6, minus b is 1. So in conclusion, we found out that x square equals to the value of square root of 6 minus 1 square, according to this trigonometric identity, equals to 6 plus 1 minus 2 times square root of 6. And we should not forget this expression also, this part of the equation. 2 times square root of 3 square equals to 2 squared, that is 4, times square root of 3 squared, that is 3, and 3 times 4 is 12. In conclusion, we found out that x squared equals to 6 plus 1 plus 12 minus 2 times square root of 6. That is to say, x equals to 6 plus 1 plus 12 is 19, minus 2 times square root of 6 units. Okay, this is the value of x squared, of course. Here we took out of this equation, and we found out that x equals to either the square root of 19 minus 2 times square root of 6 square, or in terms of numbers is 3.75 7.55 units. Okay, repeat again, that's the length of AP, that is x, the line segment that we are looking for in this question. It is equal to either the square root of 19 minus 2 times square root of 6 units, all under the square, or in terms of numbers, the length of line segment AB that is equal to x, it is equal to 3.755 units. Okay, thank you very much.